So remember, the rule says if you have log base of an answer, you can always set it equal to something. So notice how these are not, you can always add that equal X or equal E or equal whatever. You can always add that. But if you have log base of an answer equals X, then what you're really asking is the base to what exponent is going to give you your answer. So you're solving for exponents. A logarithm is asking you to find the exponent. So take about 60 seconds and find those 3 exponents. And then we'll get started with 5.5.
That's so real. I think it was a mistake. Yeah. I'm gonna say 2. Okay, 2 times 2.
All right, so 3 to the what power? What's going to be my first answer? X equals -3. And that is because 3 to the power of -3 is 1 over 27. 1 over 27.
It was like your birthday. Is that a big birthday? Yeah. Why are you so dressed up right now? It's your birthday.
For number 2, 4 to the what power is 16? 2. So X equals 2. And for number 3, 2 to the what power is 64?
8. I guess.
6. All right, so if you're titling your notes, we're going to start 5.5. So draw a line. Let's get started with our new section. 5.5 is properties of logs. So the cutout that you have has the 5 properties that we're going to talk about. And actually, we're not going to talk about that last one today. I'm going to highlight, go ahead and copy down, or glue down, I meant to say. Glue down the cutout. And we're going to go through each of the 5 properties. Now, the equality property, we may not get to, but the product rule, quotient rule, power rule, and change of base rule, that's what we're going to talk about today. So take a minute and just glue that cutout down so you don't have to copy them. Glue it down. That's all of our properties that we're going to talk about.
You're needing my contacts in my contacts in general. Yeah, it's marshmallow. Yeah, because I think it's cool.
All right, so after you glue that down, you can copy down the first. We're going to start with the first one, which is the product rule. So let me just zoom in real quick and then we'll talk about it. So who remembers this from Algebra 2? So the product rule simply says, let me zoom in really close. that when you have two things being multiplied, see how I have the log of, and then I have x times y. I can expand multiplication. So what's happening here is I'm expanding multiplication with addition. So I can expand two things that are being multiplied. That expands with addition. So instead of having the log base a of x times y, I can expand it to the log base a of x plus the log base a of y. So today we're just going to go through the properties, and tomorrow we'll start solving equations that involve properties. So take a minute and copy down these two examples. We're going to expand and also condense. Thank you.
Hi, David.
So we're going to expand the log base 3 of 2x. So again, we have two things being multiplied. We have 2 times x, and that's going to expand. I'm going to break it apart. I'm going to break apart the 2 and the x. So what's really important is that you understand that when you expand it, that does not mean we just put a plus sign between the 2 and the x. That is not expanding it. Okay? When you expand it, each term gets its own log. So it becomes the log base 3 of 2 plus the log base 3 of x. So the 2 and the x each gets a log when you expand it correctly. This would be your final answer. Conversely, you also have to notice when it's already expanded. So this has already been expanded. How do we condense it? So when we see that is being added, then we condense it by multiplying. We have to know that these two things, which would be the y and the z, are actually multiplied. So this would condense down to the log base 4, and it would be a y times z. And that is your final answer. So that would be the product rule. Yes. In the parentheses? Oh, yeah, you can. Yep. Put it like this. Yep, you can do that. You could put them in separate parentheses too. Yeah. All right, so our next rule we're going to talk about that's on your cutout is the quotient rule. So let me zoom in really closely here. So for a quotient, we have division. So quotient means division. So we have division, and that is being expanded with, instead of addition, with subtraction. So instead of having x divided by y, it expands to the log base a of x minus the log base a of y. So that's how we expand division. Quotient means division. Divide. All right, so go ahead and copy down these two. Expand and condense. So it will say it. It'll say expand or condense. But if it's not just one log, then that means normally that we have to condense it.
What's here?
All right, so we have this first one that's going to expand to the log base 3. And then it would be a 4 minus log base 3 of x. So that would be expanded. And for the second one, where it says condense, we have 2 logs that are being subtracted. That's going to condense to a fraction. So it becomes the log base 3, make your fraction. 2 goes in the numerator. 8 goes in your denominator. So you have the log base 3 of 2 over 8. That can also be reduced. What is 2 over 8 reduced down to? 1/4. So I would take either one of those for an answer. All right, our next rule that we're going to talk about is our power rule. So for the power rule, let me zoom in on that cutout. Okay, there is a cutout in the front. I always want to call him by his brother's name. It's so weird. It's not even his name. It's his brother's name. Okay, it's so weird. Okay, so for the power rule, we have an exponent right here. And when you see an exponent, the rule tells us that that exponent can be moved to the front. So an exponent becomes multiplication. So when you see an exponent, it becomes multiplication. So that's that next rule. So take a minute and copy down these 2 examples for expanding the power rule. So we're on power rule now. Yeah, because I don't use them again till 5th, and then it'll be all over the floor. So when you see an exponent, see how we have this 5? Whenever you see an exponent, we just move it to the front. That's what that property says. So it just goes to the front. And when it goes to the front, oh, okay, it's okay. So when it goes to the front, you have 5 times the log base 4 of x. That would be your answer. That would be your final answer. So if you see an exponent attached to your answer, we move it to the front, it becomes multiplication. And also, going the other way, if you see a number that's being multiplied by a log, we can move that and it becomes an exponent. So it would be log base 3 of 2 to the 4th. And that would be your answer. All right, and our last property that we're going to go over is the change of base. So remember on Monday I said that your calculator, most calculators only have 2 log keys, a log and a natural log. So that means that if we want to figure out what a different base is, we have to do a change base rule. So change base rule is pretty simple. When you do a change base, if you have a base that is not already in your calculator, so if this number here is not a 10 or an E, because those are the only 2 keys we have, we're going to change it. And when we change it, we're going to use one of the 2 options that we have in our calculator. So we're going to change it to a common log, which would be a log. Divide the log of x by the log of a. So whatever base was in the original question, we're going to divide it by the log of that small number. Or we can use the natural log and do the natural log of x divided by the natural log of a. So when we do our change base, we're going to change it to either a natural log or a common log. So take a moment and copy down these 2 examples where we just evaluate. Because remember, when we evaluate, we're trying to figure out 5 to what power is 75? Well, that's not going to be a whole number. We can't multiply 5 a whole amount of times and reach 75. That's a decimal. And we know that it's going to be a number between 2 and 3. Because 5 squared is 25 and 5 to the 3rd is 125. But that answer is actually a decimal. So what we're going to do is we're going to use our calculator. Because we don't have a base 5 key, we don't have that as an option. We're going to change it to a base 10 or a natural log. So when you type it in your calculator, you can either type it in as a common log. So we're going to put in a fraction. You're going to take the log of 75 divided by the log of 5. That would be your first way to do it. Or you can use your natural log and type in the natural log of 75 divided by the natural log of 5. So go ahead and type that in your calculators. I'll put up the correct answer. And if you're not getting that answer, raise your hand and I will help you type it in. But the correct answer to A is x is approximately equal to 2.683. We're just going to round to the thousands place. So that should be the answer you get if you type it in correctly. So go ahead and use your calculator. Practice typing it in and see if you get that. If you don't get that, raise your hand. I'll help you. You may have to close the parentheses after 75 on the calculator for it to work. Does anybody need help typing that in? Anybody not get 2.683?
So you'll get the same answer despite whether you put like the L in or the
Yep, and you can test it. Go ahead and type it in too. Type in natural log of 75 divided by the natural log of 5.
Okay.
So type it in both ways. You should get the same answer. Whether you use common log or natural log, you should get 2.683. Okay. So when you do this on the test next week, it doesn't matter which one you use. You can't use different ones. Like you can't put a log in the numerator and a natural log in the denominator. It has to be the same. But you can either go log or natural log. Okay? Try to do B by yourself. See if you can type that in, figure out how to type that in your calculator. So we have to do a change base. Oh, wait a minute. Before you do that. So what we just figured out is that, let's go back to the original question, is that 5 to the power of, if you were to type this in your calculator, you can always test this. So if you type in 5 to the power of 2.683, you're not going to get exactly 75, but you're going to get really, really, really close to 75. That's how you can test that you got the correct exponent. So who got something close to 75? You should get like 75.05. Okay, which is really close. We can't get it exactly because it's a decimal, but that's as close as we can get it. All right, try to do part B by yourself. So for this one, you're going to either type in the log of 18 divided by the log of 7, or you can type in the natural log of 18 divided by the natural log of 7. If you type it in correctly, you should get that your exponent is 1.485, approximately. Who got that? So if you type in your calculator 7 to the power of 1.485, go ahead and test that. You should get something really close to 18. It's not going to hit exactly, but we should get close. So 7 to the power of 1.485 is 17.989 or 988. So really, really close, but not exactly that. Okay? All right, so those are our properties. So let's do a couple more. Expanding. We're going to do condensing. So take a minute, copy down these. We're actually going to do just A and B. So go ahead and copy down these two, and then after that, I'll show you your quiz. So take a minute, copy down these two, and then we'll end there for today. Technically, anytime you round it, it should be the squiggly, but I would not, yeah, that's okay. Now, I don't know about your college professor, but I would not mark that wrong. So we're going to use a couple of properties in this one. So we're going to condense it. When you condense, whenever you're condensing, you should only have a single log. A single log. So when you see how we have a log in two different places, that's how I know that this is not condensed. Okay, so we'll do B and C, skip over A, show you your quiz. The deadline to retake chapter 4 is tomorrow. The deadline to retake the chapter 5 quiz is next Thursday. So you have a week, a little bit more than a week to get those retakes in. We have one test over chapter 5, and then we have, I believe it's going to be a quiz over chapter 12. I'll know for sure. And then we're done. We get ready for our final. Okay, so for this first one, what is this subtraction sign telling us to do? Yep, so whenever you see a subtraction is going to condense to a fraction. So subtraction means we have a fraction. That's how I like to think of that. So I'm just going to have my log base 3, and I make my fraction. The 4x goes in the numerator, and the 8y goes in my denominator. So it'll simply be log base 3 of 4x divided by 8y. And that would be your answer. Now, question C actually has two properties. We have addition, which means we're going to condense it down to what? Multiplication, but we also have an exponent. So do you see how we have, anytime there's a number in front of a log, that means that that's an exponent. So first step we're going to do is move these exponents in this correct position. So that would become the log base 5, and then it will be 2x to the power of 4 plus the log base 5 z to the 4th squared. Okay, but we're not, oh, I'm sorry.
So
It's okay.
you said that 8 would be incorrect.
Yep, you're one step ahead of me, but you could do that, yeah, that's okay. So now the next thing we're going to do is, what is addition? Addition means that we're actually going to multiply. This and this are actually multiplied. That's what this plus sign is telling me. So it's going to condense one more step. So log base 5 of 2x to the 4th times z to the 4th squared. So this would be perfectly fine for me. But again, most of you all are going to somebody's school, and they will probably want you to keep going, which means that they will want you to simplify that exponent. So the best answer would be the log base 5. And now you're going to take 2 to the power 4. What is 2 to the power 4? 2 times 2 times 2 times 2 would be what? 16. And then we have x to the power 4. And then, like Trayana said, we have actually z to the power of 8. This is the best answer. But I'm not picky. I'll take either one. Okay, so when I call your name, you can see your chapter